In the given figure, they're asking the area of the segment ACB. Now, observe this particular figure over here. To calculate the area of the segment ACB, that means this area. What we need to calculate, first of all, we need to calculate the area of the sector. And after, from the area of the sector, if we subtract the area of this triangle, that is triangle AOB, I'll get this area, required area. So let's first talk about the area of the sector. Area of sector is very simple to calculate. We know the formula. Formula is theta by 360 into pi r square, right? Theta over here is clearly given to me, that is 120 degree. So 120 degree by 360 degree into pi r square. R I'll keep in the form of r because they have to give it the answer in the form of r. So 120 cancelling out 360 degree 3 times. Our area of sector comes out to be pi r square by 3. Alright, then area of the triangle. Now this is tricky. How would I calculate the area of the triangle? Generally the area of the triangle can be easily calculated if we have angle as 90 degree or angle as 60 degree, because that forms the area of equilateral triangle. In this case, over here angle is 120 degree. Neither of the case works. So first of all, I need to find out few things, like what? So if I do a construction over here from O, from the center, I draw a perpendicular on this chord. From O, if I draw a perpendicular on this chord like this. This is a perpendicular I have drawn over here. If I have drawn a perpendicular from the center of the chord, just divide the chord into two equal parts. This is a property of circle. So let me call this part, this much part as B, and this perpendicular, let me call it by the name P. Let me call it by the name P. So now observe this right angle triangle. Since I have drawn a perpendicular, this will be 90 degree. I have to use some trigonometry. This is a holistic question involving properties of circle, areas of circle along with trigonometry. So in triangle, if I give it a name, let me give it a name. Let me call this point as M. So in triangle AOM, if I take a trigonometric ratio, so for that I need some angle. What will be this angle? Is it difficult to calculate? This angle, observe over here, this is R, both being R, so that means both sides are equal. That means both angle would also be equal. Both angle equal, so then in that case, in the triangle, 120 degree plus x equals to 180 degree, right? So from here, x value will come out to be what? X value will be coming out to be 30 degree. So this angle over here is what? 30 degree. This angle is 30 degree. So angle is 30 degree. Now I can take the trigonometric ratio as sine of 30 degree. Sine 30 degree is what? Sine 30 degree will be perpendicular, which I have assumed to be P, upon hypotenuse. Hypotenuse is R over here. So sine 30 degree value is 1 by 2 is equals to P by R. From here I have the value of P, that means perpendicular in terms of R, that is R by 2. Fine. Another trigonometric ratio which I can consider over here is the cos of 30 degree. Why is a cos? Because I need the value of B as well. So cos 30 degree is B by R, that means base by hypotenuse. Cos 30 degree is root 3 by 2. Root 3 by 2 is equals to B by R. In terms of R, I'll have the value of B, which will come out to be what? Root 3 by 2 into R. We have the base, we have the perpendicular. Now base is only this much length from A to M. I need what? I need the value of AB. AB will be twice of AM. So from here 2 into root 3 by 2 R square. I get not R square, simply R. So I have the value over here of AB, that is root 3R. This is, now I have the complete base, I have the perpendicular length. So area of triangle will be half into base into height. Half into base into height, putting up the value. So this is half into base. I have calculated to be AB is the base, so root 3R, height being the perpendicular height, we have calculated P, that is R by 2. So into R by 2. The value of the triangle comes out to what? Root 3 by 4 R square. We have the two areas which were required to calculate the shaded region. Now for the shaded region, we are short of space over here, so I am writing over here required area. This is the required area. This will be basically area of the sector, that is pi R square by 3 minus root 3 by 4 R square. R square is common in both the terms, so I'll take R square common. What is left? Pi by 3, and in the second term what is left? Root 3 by 4. So we have the answer over here in terms of R square, which is whole, in the bracket pi by 3 minus root 3 by 4. Which option matches our answer? I can see option number A is matching, and hence that is our answer.